Okay guys, so we're looking at conic sections. This is part 5 of the unit. We're going to be looking at equations, and we want to be able to identify the type of conic section that we have. And these equations are going to be in a bunch of different forms, and that's what makes it difficult. Because some of them are going to be in standard graphing form, others are going to be in what we call general form. Standard graphing form is the form that we like to see because we can immediately see we go out 2 in the x direction, 3 in the y direction, and be an ellipse. But this is the same ellipse in general form. How in the world is this the same as that? What do we do, Ethan? Okay, right. So if we were over here and we divided this whole thing by 36, we would end up with that. Or if we took this equation and multiplied it by 36, we would end up with this. So you can see they're equivalent. If you weren't sure of that, you could go to Desmos, and there is the first one in standard graphing form, and if I look at it in general form, it's exactly the same thing. So what we're going to be taking a look at is, so what if I change this from plus to minus? What type of shape do you think we would get? If I change this plus right here to subtraction, what do you think? You're right. Yep, Tyler. It's going to end up being a hyperbola. So watch if I do that. See how now it's a hyperbola that opens in the x direction? Okay, I think you said y, but it would be in the x direction because x comes first. Okay? And then even if I change this to a negative, any predictions on what would happen if I changed the 1 to a negative? Well, if I change the 1 to a negative, I would then, yeah, it's going to change the direction, isn't it? So if I do this, see how it's still a hyperbola, but it just flips it around that way? Because I would have to divide the whole thing by -1, so therefore this term would become positive, and it would have to go first. So that's the kind of thing we're going to be doing. We're also going to take a look at circles. Of course, all of you know that's a circle. But what happens if we have x squared plus y squared equal to a negative? Watch what happens. Nothing. If I have a closed figure, meaning a circle or an ellipse, a circle and an ellipse can never be equal to a negative on that right side, or else we don't even get any type of shape. Closed figures, again, are circles and ellipses. Let me go back here. Right now this is a hyperbola, but if I change this to a plus, I have nothing. And that's because this part is an ellipse, but it's equal to a negative, and therefore we have nothing. Now, if I were to change this back to a positive, now we're back to having an ellipse. All this is stuff that we have to be thinking about. All right, so let's go back to the notes now. So this is called general form right here, and if we have a function that's in, not function, I should say an equation rather, that's in this general form, when a is equal to b, meaning that the coefficient of x squared and y squared are equal to each other, then we might get a circle. The reason we might get a circle is because we have to check for does not exist. When does the equation not define a circle? We just looked at that on Desmos. When it's equal to what? A negative. So that's going to be if I have x squared plus y squared equal to any negative value. Now it's no longer going to be a circle. This would be D and E does not exist. A circle is what we call a closed figure because it's, you know, it's closed. There's no other way to describe that. If A does not equal B, but A and B do have the same sign, then the equation may define an ellipse. All right, so what am I saying there? Well, that's like this example up here. A and B are not equal to each other, but they're both positive. So it could be an ellipse, but it could also be that it does not exist, like we looked at. If I have 4x squared plus 9y squared equal to a negative, that's actually going to be does not exist, because we can't have it equal to a negative because it's the closed figure, and we looked at that. All right, now the third thing that can happen. A and B have different signs, then the equation will always be a hyperbola. Okay, this is important. A and B have different signs. It does not matter what's over here. If A and B have different signs, it's always going to be a hyperbola. Remember how we looked at that? Let me go back to Desmos one more time. Let's go to this one. Okay. This is a hyperbola, right? A and B, A is positive 9, B is negative 4. They have different signs. It's a hyperbola. Even if I made this a negative, what happened when I made it a negative? It just made it open instead of in the x direction, in the y direction. It's still a hyperbola. So if A and B have different signs, it's easy. It has to be a hyperbola, no matter what. Okay? It can be equal to anything. Okay? So it's only for the circles or the ellipse, when these signs are the same on the ellipse, but it's equal to a negative, that's going to be when we have nothing. It does not exist. All right, and then if only x or y is getting squared, meaning that a or b equals 0, then the equation defines a parabola. Here's what's happening with that. Let me go back here. The same problem. I'm going to make it so that only x is getting squared and not the y. See how that gives us the parabola? Only x is getting squared, not the y. That's a parabola. Let me switch it up. Get rid of that. And now we're going to have only, and by the way, while we're here, if neither x nor y is getting squared, what do we have? A linear function, a line. But if I make this, see how now it's going to still be a parabola? Okay? Even if I change this to a negative, you guys, it's still a parabola. Does not matter. Okay? All right. So if only x or y is getting squared, then it has to be a parabola. So that could be like 4x plus 9y squared equals anything, whether it's positive or negative, it's a parabola. So for closed figures, you must check to determine whether real solutions exist. Which of the conic sections are closed? I said it just a minute ago. What are they? Circles and ellipses. All right, I'm going to do this first problem with you. Tell me what A is. What's the coefficient of x squared? 3. What's the coefficient of y squared? Negative 4. You have to take the sign. A is 3, B is negative 4. The signs are different. You should know what kind of shape we have. What is it? Hyperbola. We don't have to do anything else. It has to be a hyperbola. On number 2, what is A? What is B? A and B have different values but have the same sign. What is it probably going to be? An ellipse, but I have to check. Here's how I check. I'm going to have to complete the square. Now, I don't have to go all the way through this problem. I will show you where I can stop. All right, so I'm starting completing the square. Does everybody, that's 61, not 60. Does everybody understand how I got this? All right, so now I'm going to start completing the square. Okay, so to complete the square, I have to take half of this and square it, and I have to take half of this and square it. So what I really added was how much? 16 there, and then how much here? 81. Now, when I have an ellipse, all I have to do is make sure that that's going to be a positive. Is it going to be a positive? I don't care what it actually is. I just need to make sure it's equal to a positive. I really could have stopped right here. How would I know I could have stopped right there? Ethan?
Because you're only adding value.
Exactly. I'm only going to be adding on more to 61. It's definitely going to be positive, right? So therefore I know this has to be an ellipse. All right. We're going to do one more, and then you guys are going to do a couple. Okay, number 3. A is 5. Actually, A is what? What's the coefficient of x squared? Do we have an x squared term? So A is actually what? 0. B is the coefficient of y squared. You should already know what it is. It is a what? Parabola, right? Okay, I want you to take a minute and try number 4. Sophie, what do you think? Does not exist. I heard an awful lot of people saying circle. Which is it? Does not exist or circle? Does not exist, guys, because if I take this over here, I'm going to have 10x squared plus 10y squared equals negative 20. That's exactly what we just talked about. That cannot happen. If you put that into Desmos, you're going to get nothing. This does not exist. Okay? Got to check for that. All right, you guys try number 5 now. What are you going to do first to make the problem easier before you do anything else? Multiply through by negative 1 before you do anything else. I want you to stop as soon as you can, as soon as you know what it is. You don't need to go all the way through these. Eli, what do you think?
Circle.
Do you guys agree with him, circle? He's right. You should agree. How did you know that, Eli? What'd you do?
I put A equals 1, B equals 1. Since they're the same, and then you're adding positives, negative 12, positives, wow.
In fact, how much are you going to end up adding? You got to make sure you're adding enough.
Yeah, you'll be adding
13. Because we're adding just enough to make that positive, it is going to be a circle. But do you see how at the beginning you might be thinking, uh-oh, that's not going to be a circle. But you got to make sure you're going to add enough when you complete the square that we get a positive over there. All right, guys, think about number 6. This should take you all of about 15 seconds. Reese, what do you think?
Circle.
Do you guys agree circle? Ethan, what do you think?
Say ellipse.
You say ellipse? What do you guys think? Circle or an ellipse? An ellipse. Guys, if I ask you for the coefficient of x squared, if I asked you what A is, what would you say? 4. Very nice. A is 4. B is actually 1/9. Nice. So this, whenever A and B have different values but the same sign, that's going to be an ellipse. In fact, I would have to go out 1/2 in the x direction and 3 in the y direction, create the box. It would be real small, but we could do it. Okay, number 7. Samantha, what do you think? Ellipse? Grace, do you agree? You say an ellipse too? Does everybody agree it's an ellipse? Izzy, why do you disagree? Does not exist? You're getting a lot of nods on the does not exist. Can somebody explain why it does not exist? Ari? Yes, it's right here. It's very tempting to say it's an ellipse because we have a 1/4 and a 1/9, but because an ellipse is a closed figure, it's not allowed to equal a negative. In fact, if you went to Desmos graphed it, you'd get nothing for this. This does not exist. But I do understand why we think it's an ellipse, but you gotta check that it's not equal to a negative. All right, number 8, last one. Ethan's already ready. What do you think, Ethan? Hyperbola? Eli, what were you gonna say? Hyperbola? Do we all agree? But it's equal to a negative. It is still a hyperbola? Right. This is not a closed figure. It's an open figure. It's allowed to be equal to a negative because all that does is switches the direction it opens. You are correct. This is a hyperbola. So a whole big section of our test, not big, but like 10 points worth, is just going to be over identifying these. Now let me throw one more in here at you. What if I gave you 4x plus 9y equals 1? Or negative 1 even. What are you going to say to that? Linear. It's a line when we graph it. Okay? All right, very good. So make sure you go back. If we have closed figures, meaning circles or ellipses, those are closed, we have to make sure it's not equal to a negative. If it's equal to a negative, it does not exist. The others are okay. All right, very nice.